So, hi, I am Merkel in BSIN Base MT1 from Betelgeuse. So, now I'm gonna discuss the free surface effect. So, free surface effect refers to the tendency of liquids in partially filled tanks or compartment to shift when a vessel rolls in or pitches, affecting its stability. If this is the ship's transverse section, let us assume that the ship's floating in still water at upright condition, and this is the water line. This is the water line here. The bottom tank is partially filled with water, and let us say that the center of gravity of the water inside the tank is here. And we will mark it with a small letter G here. If this is the center line and this is the point of the ship's center of gravity, we will mark it with the capital letter G here. The geometrical center of underwater volume is the center of the buoyancy here, and we will mark it with the capital letter B there. Where the buoyancy force acts vertically upward, for a ship to float, the buoyancy force should be equal to the total weight that acts vertically downward here. When the ship tilts or rolls, the ship's center of buoyancy, capital B, moves to some point at the low side to be one of the liquid within a partially filled tank, tends also to move to the lower side, causing the shift of the center of gravity of water inside the tank. As small g moves the vessel, center of gravity also moves parallel to the movement of the small g. Now, the point where the buoyancy force and the ship's center lines intersect is called the transverse metacenter, capital M, and the horizontal distance between the ship's center of gravity, capital G, and the vertical line of buoyancy force is called the righting lever, GZ, which determines the ability of the ship to return to its upright position when she is tilted. This is supposed to be our righting lever if the water inside the tank is solid and does not move, or if the water is in solid form or frozen. But since the water inside the slack tank is free to move due to its movement, the ship's center of gravity, capital G, moves in a parallel direction with the center of gravity of water inside the tank. The present righting lever of the ships at this moment is from G1 to Z1. If we extend the downward vertical force upward intersecting the center line, the point of intersection will be GV, or the virtual rise of the ship's center of gravity. The horizontal distance between GV to ZV is equal to G1 and Z1. The movement of the water inside the slack tank here when the ship is heeled result in a decrease in the ship's righting lever here. This is supposed to be our ship's stability triangle if the water inside the tank cannot move here. This is supposed to be our triangle if the water inside the tank cannot move here. The result is a reduction in the ship's stability due to slack tank. So now, in this case, we can say that the distance between GV to M is the GM fluid here. Here are the GM fluid. And while the distance between G to M is called the GM solid here. Is the GM solid. And now the distance between the capital G to GV is the virtual of GM, or usually we call the free surface correction, or FSC here. I'm gonna do this one here. This is the free surface correction. And that's all for my video discussion.